Okay, so are you guys all on your assignments?
Yep.
Yes.
Okay. So, number 4, what did you guys say? I said normal.
Normal.
Okay.
Normal.
Then 5, normal.
Yep.
Okay. Number 6, the these. Well, I got 16% or 0.16.
Wait, what?
Um,
No, 1 second. Oh,
Okay.
yeah. Well, yeah. I got 0.1587, but I didn't round up,
Okay.
so.
Yeah. All right. And then number 7, I got 95. Well, yeah, 0.9545.
Okay.
Okay. And then number 8, I got 0.9545.
Yeah. It's the
And
same
then,
thing because of the standard deviation is within that 2 and -2.
yeah, it's 2 standard deviations both times. And then number 9, got 0.0062. Okay, number 10, got right skewed.
Yeah.
And then 11, normal. 12, central limit theorem. 13, no, because outputs for a bell curve and not for right skewed data. And then 14, 0.9599. And then 15, I got 0.7887. All right. Great.
Okay, are we ready to go?
I just invited Abby, and so let's wait for her to get on
Okay.
before we do this quiz. Okay.
Okay, there we go.
Great.
I'm like panicking. I'm like, no, I'm here. I am here. Don't worry about going over the other things. I'll look over it, and if I have any other questions, I'll ask about them.
Yeah. Okay.
But
And we'll post the videos too, like on discussion board, so you can look at it
okay.
to see what we.
Okay. So where are we at now then?
Okay, we're about to start quiz number 7.
Okay. Let me just pull it up real fast.
All right. Sounds good.
Let's see. You said quiz 7, right?
Yeah.
Sorry, you guys can get started. My computer's being a little bit slow.
Okay. For number 3. Okay. Use the normal probability app to find the combined area under the standard normal curve to the right of 1.358 and to the left of negative 1.358, and round your answers to the decimal places. Okay, so we're going to go outside of that area. I got 0.1745.
Yeah.
So do we add the 0.087 together?
Yeah, I think so. There we go.
I'm sorry, what did you guys say you guys got?
0.175.
Mm-hmm. Would it be 174?
Well, it says round to 3 decimal places, and so it's 745, and so you round that up.
Oh, wait. Wait, what was the area before we added them?
Well,
Well,
I just clicked on to shade both of the outsides.
yeah, when you only click on one of them, it would be,
I see.
you get the wrong one.
Okay.
Yeah.
I was adding them up, but sorry.
No problem.
Okay.
Yeah, it's like slightly different though.
Number 4, the United States Coastal Guard assumes that the mean weight of the passenger in the commercial boat is 185. And the previous value was lower, but was raised after a tragic boat accident. The standard deviation of passenger weight is 26.7 pounds. The weight of a random sample of 48 customer boats passengers were recorded. The sample mean was determined to be 177.6 pounds. Find the probability that the random sample of passenger will have the weight as extreme as or more extreme than was observed in this sample.
Okay, so we do 177.6 minus 185, and then divide that, and then we take 26.7 over the square root of 48. Okay.
I got negative 5.126.
Okay.
Or 127. Is that what you guys got?
Hold on.
What did you say you got?
I got negative 5.127. That's just solving the problem here.
Oh, for like 177 minus 185.
Then do we plug that in?
So what did you get again?
Me?
Yeah.
Negative 5.2, I'm sorry, negative 5.127.
And how did you get that?
I did the 177.6 minus 185 divided by the 26.7 divided by the square root of 48.
Okay. Hold on. I need to get my scientific calculator. There we go. I got negative 1.920. Did anyone else get that?
I'm recalculating. Just a sec.
Okay.
I got negative 1.92.
Okay.
Maybe it's me. Yeah, I'm sorry.
Okay.
1.920, whatever it is.
Yeah. Great.
So is that the answer, or do we have to plug it in somewhere first?
Let's see. Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme than the sample. So yeah, we need to plug it in.
And it said more than or less than, right?
Yeah.
As
Well,
as extreme or more, not less.
Oh, okay.
so
we
zero-
should need it.
0.9726.
That's what I got. Yeah.
Yep.
So I guess if we're rounding it just to the 3, then 0.973.
Yep.
Yeah. Okay.
Okay, number
Okay.
5. Which of the following? Oh,
It's good. Do you want me to do the next two? Since I kind of missed out on what was going on earlier.
Sure.
sure.
Okay. So which of the following will have a smaller deviation if 9 observations are randomly drawn from a population? So A is the distribution of the individual observations is X. The distribution of the sample means X with the little line over it. Or this cannot be determined from the information given. Distribution of individual observations.
I think it would.
Just a second. Let me.
Okay.
Wouldn't it be B?
Yeah, that's what I think.
The
Too.
mean, right?
Yeah.
Let me just take a look real fast.
Wait,
Okay.
can you guys explain why, like the rationale?
Because
I'm pulling it up really fast. That's why. So when you look in lesson 7, when it's talking about reviewing the sampling distributions, and it says when the sample mean normally distributed, or approximately when is the sample or the norm mean normally distributed, and it's just asking a question, and then it says the parent population is normally distributed, so the sample mean is automatically normally distributed. The sample size is large, and the central limit theorem implies that the sample mean is normally distributed. For the mean of draws from a random variable will mean that the mean of the random variable is the x over the line. I don't know if there's an actual word for it. Is a particular number. Does that make sense? Like,
yeah, it does.
I don't remember the names of the symbols, so I'm describing them.
It's okay. I think I remember reading that too.
So it would be the distribution of a sample means the x over that, and there would be additionally, there's other equations that you can put in, but it would mean that. That's what it means in the equation, is the sample mean.
Okay.
Which of the following results implies that the spread of x decreases as the sample size increases? Wouldn't that spread in decreases sample size? Isn't it the law of large numbers? Which of the following results implies?
The law of large numbers says the greater the amount of observation or sample, the sample mean draw closer to the population mean.
So the spread in the mean decreases as the sample size decreases.
I think so.
yeah, that makes sense.
Yeah.
Does anybody think it might be anything else? I think it is that. Just the way it's worded is kind of weird.
So it's the law of large number, right?
Yeah.
Mm-hmm.
Okay. Okay, let's see. You want to take 7?
Sure. Scores on the quantitative portion of the GRE are approximately normally distributed with mean 150.8 and standard deviation 8.8. Use this information to answer questions 7 through 10. So Diane earned a score of 160 on the quantitative portion of the GRE. What is the z-score corresponding to Diane's score? Round your answer to 3 decimal places. So z-score I got for her is 1.045.
Yep.
So did you just take 160 minus 150.8 divided by the standard deviation?
Yep.
All right. So number 8, what is the probability that a randomly selected student will score above 160 on the quantitative portion of the GRE? And so we just take that z-score and then plug it in. 1.045.
Wait, Alyssa, what did you say you got for 7?
1.045.
1.045.
And this is what is the probability that a randomly selected student will score above? Okay.
Yeah. And so you just plug it in.
0.1480.
Yeah, that's what I got.
Yeah.
Okay, so 0.148.
Yeah.
Sorry, can you repeat number 8 again?
0.148.
Okay.
Does that make sense?
Once you guys solve for z-score, you just plug it in, right? And then...
Yeah.
Yep.
Yeah.
what? I'm confused. Hold on.
Okay.
Wait, so number 7 was we took 160 minus 150.8 divided by standard deviation 8.8. I got 1.045, right?
Yep.
Right.
And then on 8, do I just go into the applet and apply
Yeah.
it in the...
Yeah.
Okay, 1 second. Hold on. 1.045. Oops. Okay, and then I got 0.148, right?
Yep.
Yeah.
Okay. Okay. Now, sorry, I was like confused.
No
Okay.
problem.
No, it's okay.
Number 9, a random sample of 5 students was selected to take the GRE. Their scores are 160, 175, 163, 149, 153. What is the score, Z-score, corresponding to the sample mean of these students' scores?
Hmm.
Do we find the sample? Do we find the mean of the sample first?
Yeah, I think so, and then use the mean above and the standard deviation up there. So.
I got 677.6 for the mean. I don't know if I'm doing that right.
What did you get?
677.6. Probably wrong.
I don't think it should be 600 for the mean.
So you add all those numbers and then divide by 5, right?
Yeah.
Divide by the number of things, so yeah, it would be exactly that.
Weird. Hold on. I got 160.
Yeah, I got that too.
Sorry, my calculator, I need to do certain things to it for it to come out right. So then we take one, it's the same thing then, right?
Yeah.
Then we take 160 minus 50.8 divided 8 by 8.8. Wouldn't that be the same as the 1.045?
Well, no, because we're using a different sample size, and so we do it 160 over. Yeah, it's 26 point or whatever. Yeah, 26. That's a different one. 8.8 over the square root of 5.
The square root of 5. Okay, that's what I was missing.
So the Z-score itself was 24.5.
I got 2.338.
Yeah, me too.
Oh,
Me too.
oh, sorry. I just moved my decimal over one, and I'm like, that's still too big.
Yeah.
So we said 2.33.
8.
Yeah. 2.338.
338. Okay. So, and then in the next question it says, what is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem?
Yeah, so we just plug that in and then select the part to the left. Okay.
So 0.009 or
Yeah, or 97.
0.010, wouldn't it? If that's rounding it up to a...
This one, it says round to 4 decimal places.
Oh, well, that's nice.
Yeah, it is good.
Okay. Suppose the mean GPA of BYU Idaho students is 3.5 and the standard deviation is 0.7. It is well known that this distribution is left skewed. A random sample of n equals 81 students will be drawn. Use this information to answer problems 11 through 15. What is the shape of the sampling distribution of the random variable x, which represents the sample mean of 81 students who are selected?
Wouldn't it be approximately normal?
Yeah.
Yeah.
Because the sample.
The sample size, even though it's left skewed, the sample size is 81, which is considered large. Then it would be approximately normal. I don't know how to explain.
Yeah. Okay. What is the mean of the distribution of the sample means? Sampling distribution for all possible sample sizes of size 81 that could be drawn from the parent population. 3.5, standard deviation of 0.7.
What is the mean of the distribution of the sample mean for all this? So do we take? Oh man. How are you guys doing this problem?
I don't know.
No idea.
So the information that we're given is, suppose the mean GPA of BYUI students is 3.5 and their standard deviation is 0.7. It is well known that the distribution is left skewed. Random sample of n equals 81 students will be drawn. But the question is, what is the mean of the distribution of sample means? Let me look up on the chapter real fast.
Okay.
Let's see.
Would that be the mean? Wouldn't it just be the 3.5?
Well, it's asking the mean of the means. Mean of the distribution of the sample means. And maybe I'm just thinking about that too much. But it can't be that easy, can it?
I don't know, honestly. Like,
Like, it can't be that easy, like it's right in front of us kind of thing.
Yeah.
Well, it says that could be draw for the parent population. Isn't the parent population mean would be 3.5?
Yeah.
Yeah. So they're saying, what is the mean of the distribution of the sample means? Good grief. Okay, I'm continue reading in lesson 7. What's that?
That's the only information we have, and so I don't think that it could be anything other than that.
Yeah.
But I don't know.
Okay, I think I'm just overthinking it. I'm like looking in the chapter and it's just like talking about how you get the mean and whatnot. And
Yeah.
I think I'm just overthinking that.
So I would say it's 3.5 then.
It should be.
Yeah.
Yeah.
Okay, so
Number 13. What is the standard deviation of the sampling distribution of the random variable x? The mean of 81 students who are selected. The standard deviation is 0.7. What the heck?
But then don't we
Exactly. Like that's what my brain is thinking. It's like it can't just be that easy of just plugging in those numbers, can it?
Well, it would be.
Well, don't we do 81 over the square root? No. Okay. Do we do 0.7 divided by the square root of 81?
Yes.
Okay.
Square root of 81. 0.0086. Well, let's see. How
I got
long do we
0.078.
Me
have?
too.
7, 8. Let me try that one more time. Did you round it all?
Yeah.
Okay, I'm like, because we're going to the first three, so it'd be. So why did you round up to 007 or 07?
0.78.
Because it's 0.0777778.
Oh, okay. Okay.
All right. Number 14. The probability that the mean GPA for 81 randomly selected BYU Idaho students will be less than 3. What is the probability that it will be less than 3.3? So we just find the z-score and then plug it in. So yeah.
I got 0.0051.
Yeah, I got the same.
Great.
Can you guys repeat what you guys just said?
Yeah, I got, once you find the z-score, which is negative 2.57, you plug that in, and then you shade to the left of that, and then you get 0.0051, but we round off, so it's 0.005. Did you get that?
Okay. I think I just have a little lag time in my mic, so I'm kind of hearing an echo.
So would 15 be the same thing, 0.005 then?
Let's see. What is the probability that the mean
greater than-
GPA?
So it's 0.9949, right? Wait, what?
So if it's greater than 3, we shade everything to the right of negative 2.571. So it's,
Did you
did you
get?
get 0.995?
Yeah.
Okay. Great.
Cool.
Did she get that too? Did.
Yeah, that's what I got.
Okay.
Okay. Should we submit it?
Yeah.
Yes.
We got number 4 wrong.
Yeah.
Okay.
I'm not sure why we got it wrong.
Let's see.
How do we do number 4 again?
Let's see.
Did we need to plug it in though? Find the probability.
Yeah.
Yeah, we did.
Weight that extreme or more extreme. We plugged it into the applet, didn't we?
Yeah, it's possible that like the wrong area, like we selected the wrong area for the probability. I'm sure, like, because that's the only thing I can think that it would be, since, you know, we all got the same Z-score.
Yeah, because it was extreme or more extreme. So maybe I accidentally
We had the middle or something.
highlighted just the middle or just the top instead.
Yeah.
I just did it again, and it's... I don't know. I don't understand how it's wrong.
Did you do both of them and it's still the wrong answer?
Yeah.
That's weird. Did we not round up properly? Let me see that again. I gotta open up my applet.
No, it's rounded up fine.
Maybe we should email her and ask her. .7, 2.6, 85 pounds.
I don't know.
So what did you guys select when you had the applet open?
I select everything to the right.
Yeah, that's
I
what I
don't
did.
think that we're supposed to select
extreme
the
or-
middle. I think we're supposed to select the two edges because it's saying, like, what's the probability that the weight is this extreme or more extreme.
That's right.
And so if it's going to be that extreme, then it's not going to be the mean, anything, you know, to do with the mean
Oh.
in
Oh.
the middle. So that's why I think it.
0.055.
Yeah. Yeah.
Okie dokie.
Oh, well.
Yep. That's okay.
C'est la vie.
Okay. So for our next meeting, when can you guys meet for, I guess, the next
Can we
week?
do it on Saturday again? Would that
Can we-
work for everybody?
That would be wonderful.
Yeah, that works for me.
It really, truly, honestly works out the best. And then next time I'll just automatically be on campus so that my internet connection is nice.
Okay. Alyssa, do you know your schedule?
Yeah, I have the same shift next Saturday as today, so
Okay, so do you guys just want to shoot for 9 o'clock this week again?
Sure.
Let's do it.
All right. Sounds great. See you then.
good.
Cool.
Bye.
Bye, everybody.
Okay. Bye.
Bye-bye.